Well, we're in the final stages of completion of Optimus 3, which is really going to be by far the most advanced robot in the world. Nothing's even close. In fact, I haven't even seen any demos of robots that are as good as Optimus 3, frankly. Maybe they're out there or they're secret or something, I don't know. But I think we'll start production on Optimus 3 this summer. Probably reach high volume production around summer next year. And then, we'll have Optimus 4.
Elon Musk just dropped 5 bombshells at the Abundance Summit that could completely reshape how we think about robots and artificial intelligence. This is not incremental progress. This is a complete reimagining of what machines can do. Optimus 3 is coming. Something called Digital Optimus is launching. A project literally named Macro Hard exists. And Grok is apparently about to dominate coding. Every single announcement is massive, but when you connect them all together, the picture becomes clear. Tesla is building something nobody else can match. Let's start with Optimus 3. Elon stated directly that Optimus 3 is going to be by far the most advanced robot in the world, and nothing is even close. That represents a bold statement, considering what Boston Dynamics has achieved and what Figure AI is building. Companies across the industry are developing humanoid robots, yet Elon is saying nobody is even in the same conversation as Optimus 3. Here is what makes this different from typical announcements. He is not talking about distant possibilities. He said they are in the final stages of completing it and production starts this summer. It will be slow volume at first, which makes sense. You do not flip a switch and pump out 1 million robots overnight. But by next summer, so summer 2027, he is projecting high-volume production. Then he casually mentioned they are already working on the Optimus 4 design. Optimus 3 is not even out yet, and the next version is already in development. Think about the jump from Optimus Gen 1 to Gen 2. Gen 1 basically walked around looking confused about where it was going. Gen 2 actually performed tasks, moved smoothly, and picked things up with precision. If Gen 3 represents as big of a leap as they are claiming, we could be looking at a robot that genuinely works alongside humans in factories, warehouses, and maybe eventually homes. That is not science fiction anymore. That is next year. You have to consider what this means for Tesla as a company. They have been saying for years that Optimus could be bigger than the car business and way bigger. If you can build a humanoid robot that costs maybe $20,000 to $30,000 eventually, and it can perform 8 to 10 hours of work per day, the economics become extremely large. Every factory, every warehouse, every logistics company on the planet would want these machines. We are talking about a market that does not even fully exist yet, but could be worth trillions. Now, this next announcement really blew people's minds. Tesla and Xi have been working on something called Digital Optimus. They nicknamed it Macro Hard as a playful jab at Microsoft. They literally painted the word Macro Hard on the roof of their training cluster. But jokes aside, what this actually represents is significant. Here is how it works. Digital Optimus uses Grok Xi AI model as the brain. Grok is the high-level thinker that understands the big picture and knows what needs to happen. Digital Optimus is the one actually doing the work. It processes real-time video of what is on a computer screen, specifically the last 5 seconds of activity, and controls the keyboard and mouse to get things done. Elon used a simple analogy. He said Grok is like System 2 thinking, which is the deep analytical part of your brain. Digital Optimus is System 1, which is the fast instinctive part. So Grok thinks about what needs to happen, and Digital Optimus executes it instantly in real time. The system runs on Tesla AI 4 hardware, which costs around $650. You pair that with cloud compute from Xi's side, and you have a system that can sit at a computer and function like a digital employee. Here is where it becomes more significant. Elon said this system could emulate entire companies. Entire companies. He pointed out that the most valuable companies in the world produce digital output and do not make physical products. So, if you have an AI system that can operate a computer like a human, navigate software, send emails, write code, manage databases, and handle customer service, you could theoretically replicate what an entire company does. We have been talking about AI agents for a while now, but this is different. This is not just a chatbot that can book flights. This is a system that watches a screen, understands what is happening, and takes action in real time. No other system is operating at this level. When Tesla invested in Xi, many people questioned the decision. Now it becomes clearer. Tesla has the low-cost hardware and Xi provides the intelligence. Together, they form a system that neither company could build independently. Now, step back and look at the full structure. Physical robots with Optimus 3 handling the real world. Digital systems with macro-hard handling the digital environment. And Grok improving continuously while powering both. They are not just building a car company and not just building an AI company, they are building a labor system that includes physical and digital work. If even part of this development materializes, it would affect how companies operate, how products are built, and how services are delivered. Some critics point out that Elon timelines have shifted in the past. However, the technology itself is already visible. Optimus prototypes are operating. Grok continues to improve. Hardware platforms are already deployed and partnerships are established. Elon said this would lead to an age of prosperity that is difficult to imagine. He stated, "You need to imagine it." Based on the combination of these developments, the scale of change appears substantial. Physical robots operating in industrial environments. Digital systems managing workflows through computer interfaces. Artificial intelligence handling coding, design analysis, and execution simultaneously. These systems are being developed in real time, and the pace of progress continues to accelerate.
Humanoid robots emerging as the future of warfare. The U.S. accelerating AI integration into combat operations. San Francisco-based Foundation Future Industries is developing humanoid robots built specifically for military use. The company is also scaling commercial deployment across the country in manufacturing.
Something just happened in Ukraine that is forcing the world to rethink what modern warfare looks like. 2 humanoid soldier robots have been delivered to an active battlefield for evaluation, marking a moment that many experts believe could change military history forever. The humanoid Phantom Mk1 robots were sent by the US startup Foundation, according to the company. These are not bomb disposal units. These are not remote-controlled drones. These are autonomous humanoid platforms designed specifically for combat, and they are currently being tested in real war conditions. Ukraine has increasingly become a real-world testing ground for emerging military technologies, attracting defense firms and startups from the West. But this deployment represents something fundamentally different from previous robotics experiments. For the first time, machines that walk, move, and operate like human soldiers are entering a zone where actual combat is happening. In October 2025, Foundation unveiled the Phantom Mk1, a humanoid robot designed specifically for combat and believed to be among the first built for warfare. The San Francisco-based robotics firm now plans to deploy these humanoid robots closer to the front line to refine their capabilities based on real battlefield conditions. In a recent interview with Time, Foundation co-founder Mike LeBlanc confirmed the deployment. LeBlanc said the company deployed 2 Phantom Mk1 humanoid robots to Ukraine in February. The robots were sent to the front line for reconnaissance as part of efforts to test the platform in a real combat environment. The deployment could represent the first known instance of a humanoid robot being tested on the front lines of the ongoing Russia-Ukraine war. Company co-founder Mike LeBlanc says that what he has seen in Ukraine has only strengthened his belief in the value of humanoid soldiers. He explained that humanoid soldiers could be invaluable for resupplying and conducting reconnaissance, especially in places drones cannot reach, such as bunkers. With a heat signature similar to a human's, robots like Phantom could also confuse the enemy. LeBlanc added that the aim is for the robot to be able to use any weapon that a human can use. This capability represents a significant leap from previous military robotics, which have typically been designed for specific tasks like bomb disposal or surveillance. The Phantom Mk1 itself represents cutting-edge robotics engineering. The humanoid stands about 5 feet 9 inches tall, weighs roughly 175 to 180 pounds, 79 to 82 kilograms, and is intended for tasks such as reconnaissance, bomb disposal, and other high-risk ground operations. The robot is built to operate in dangerous environments where sending human personnel may be unsafe. Potential battlefield roles include surveillance, logistics support, and handling hazardous materials during military missions. What makes the Phantom Mk1 particularly sophisticated is its technical approach. Technically, the Phantom Mk1 relies primarily on camera-based vision systems rather than complex sensor arrays like LiDAR. It also uses proprietary cycloid actuators that deliver strength, quiet operation, and backdrivability for safer human interaction. Critically, the system is designed with human-in-the-loop control. Robots manage movement and navigation, while human operators retain authority over any lethal decisions. This design philosophy addresses one of the primary ethical concerns surrounding autonomous military robots: the question of who makes life and death decisions on the battlefield. Foundation is not treating this as a small-scale experiment. Foundation is accelerating the development of military-capable humanoid robots, with plans to manufacture up to 50,000 units by the end of 2027. The company's Phantom Mk1 is designed for both industrial and defense roles, positioning it among a small group of robotic systems targeting dual-use applications. Production plans call for an initial deployment of dozens of units this year, scaling to thousands annually as manufacturing capacity expands. The company plans to lease the robots rather than sell them outright, with estimated annual leasing costs of around $100,000 per unit. Continuous operation could allow a single robot to replace multiple human work shifts in industrial settings. Phantom is currently undergoing testing at factories and shipyards from Atlanta to Singapore. The company already has research contracts totaling $24 million with the US Army, Navy, and Air Force. Tests are also planned for the US Marine Corps, during which Phantom will be trained to place explosives on doors to help troops breach buildings more safely. The company is also in close contact with the US Department of Homeland Security about the potential use of Phantom robots for patrol operations along the southern border. This suggests applications far beyond traditional military roles. But Ukraine remains the primary testing ground for combat applications. According to Ukraine's state news agency, United 24, the country conducted thousands of robotic operations in January alone, most focused on logistics such as delivering ammunition, weapons, and supplies to frontline troops. The Phantom Mk1 deployment builds on this existing infrastructure but represents a qualitative shift in capability. The implications of this deployment extend far beyond the current conflict. If humanoid robots prove effective in battlefield conditions, it could trigger a global arms race in autonomous military systems. Countries that master this technology early would gain significant strategic advantages. Robots do not require food, sleep, or medical care. They can operate in environments that would kill human soldiers instantly. They can be manufactured at scale once production systems are established. However, the deployment also raises profound ethical questions. The prospect of machines that can carry weapons and operate autonomously on battlefields has alarmed many experts. Even with human-in-the-loop control systems, the potential for fully autonomous lethal systems looms large. Once the technology exists and proves effective, the pressure to remove human control for speed and efficiency will intensify. Organizations advocating for restrictions on autonomous weapons have warned that developments like the Phantom Mk1 could normalize the presence of killing machines on battlefields. The concern is not just about current systems that retain human oversight, but about where the trajectory leads. If robots become standard military equipment, the path toward fully autonomous combat systems becomes almost inevitable. Military strategists see the potential differently. They argue that robots like the Phantom Mk1 could actually reduce casualties by taking on the most dangerous missions. Clearing buildings, navigating minefields, conducting reconnaissance in hostile territory, these tasks currently cost human lives. Robots that can perform these roles would allow human soldiers to stay out of the most lethal situations. The battlefield deployment in Ukraine will provide data that no simulation or controlled test can replicate. Real combat environments involve variables that cannot be predicted: chaotic terrain, unpredictable enemy actions, equipment failures under stress, and countless other factors. How the Phantom Mk1 performs under these conditions will determine whether humanoid military robots represent a genuine breakthrough or remain an expensive experiment. What is certain is that this moment represents a threshold. For the first time, humanoid robots designed for combat are operating in an active war zone. The data collected, the lessons learned, and the capabilities demonstrated will shape military robotics development for decades to come. Whether that future involves robots as battlefield support systems or fully autonomous combat platforms depends on choices that are being made right now. The Phantom Mk1 deployment is not science fiction. It is happening today, and the implications will echo far beyond the battlefields of Ukraine.